Student, myself Naveen Kumar, Mechanical Engineering Department, Doctor College of Engineering and Research, in Allahabad. Today, I will discuss about the another unconventional machining process, that is the latest machining process known as the electron beam machining, that is the EBM process. It is similar to that laser beam machining process, but in laser beam machining process we use of a light, highly coherent light amplification on the workpiece. But in EBM process we use of electron beam, which are useful for the electrically conductive material as well as non-conductive materials, and it is very accurate process in comparison to LBM process. Because of this machining is done in a vacuum chamber, so electron beams is not destroyed by the gases or airs, so that the accuracy of EBM process is more than laser beam machining process. EBM is the latest machining process especially to make a drill of a small workpiece. This technology used both machining as well as welding process. EBM process basically two types or two categories. First is thermal type, second is non-thermal type. In thermal type EBM process, a source of thermoelectric cathode is heated to such a high temperature that the electrons acquire sufficient speed to escape out to the around the cathode, and the stream of these large number of electrons move a small diameter of beams of electrons toward the anode. As the result of workpiece is heated by the bombardment of the electrons in a localized area to such a high temperature that is heated, melted of workpiece and vaporized the material of workpiece at the machining area at the point of bombardment. And second type, non-thermal type, in this electron beam is used to cause a chemical reaction. With the above chemical reaction we can remove the materials. Today I will discuss about the thermal type electron beam machining process. In electron beam machining process, the source of energy in electron beam machining is a highly velocity of electrons which strike the surface of workpiece and generate the heat. That is sufficient of heat which melting the workpiece materials and vaporized. Electron escape from hot surface of cathode when apply a voltage about 50 to 200 kilovolt, and this volt to accelerate them. These high energy electron beams passes high energy of density in the order of 10 to the power 4 kilowatt per mm square, and this electron beam thin and high energy stream strike the workpiece. As a result of that electron beams, the kinetic energy of electrons is converted into heat energy, and this heat energy is more than sufficient to melt and vaporize of any materials. And these electrons can penetrate only a few atomic layer of metals and melt metal up to depth of 25 mm of non-metal or electrically conductive materials. And in EBM process, the electrons beam traveling at a very high speed, about 3 upon 4 of the velocity of the sound and focused on the material to machined. And to focus the electron beams, electrostatic or electromagnetic lenses are used. Basically, we used of electromagnetic lenses. And in EBM process, generally we use of a high vacuum chamber for the avoiding the unnecessary scattering of the electrons from air or gases. So the accuracy of electron beam machining process is very high. In EBM process, on the exit side of hole, the synthetic or organic backing material is used. The electron beams, after completing the penetration it into the workpiece, also partially penetrate in the auxiliary backing materials, and this backing materials vaporize and comes out of hole at high pressure. So the machining is very fine and accurately. Here a systematic diagram of electron beam machining process. We use of a high voltage cable about 30 kilovolt to 2200 kilovolt of DC power supply, cathode grid, anode, optical beam system, electron stream, magnetic lens, deflection coil, and we use a vacuum chamber where we use of a viewing point, and work table where the workpiece are placed, workpiece, and we use of a high vacuum pump for removing of unwanted gases from the vacuum chamber. So what is the electron beam gun? It is used to produce electron of a desired shape and to focus the predetermined location. When applying a high voltage of DC power supply, the cathode grid is heated and electrons are moved cathode to anode at a very high speed, and EBM gun is operated in a pulse mode superheated cathode which make of tungsten filament type generate electron beam cloud, and the magnetic lens is used to shape the electron beam into a converging beam and focus on pinpoint the location of beam. This beam is passed through a variable aperture to reduce the diameter of focused beam and removing by the stray of electrons. And here we use of power supply, DC power supply about 30 kilovolt to 200 kilovolt. This is a high voltage power supply, and the power density at the work surface is too high, that is why it is capable to melt and vaporize the workpiece materials. Thus the material removal in EBM basically due to vaporization. Why need of vacuum chamber and machining chamber? The electron beam generation is stable in the space and resulting machining take place in a vacuum chamber. The vacuum does not allow rapid oxidation of filament, so that the life of filament is very high and there is no loss of energy of electrons by moving of unwanted gases or airs, and it is also use of viewing port, where use of machining, and use of a high vacuum pump for removing of the air or gases from the machining chamber. So the working principle of electron beam machining is done in the closed chamber, is known as the vacuum chamber, for the improving the efficiency of machining process and accuracy of the machining, where it is required for very deep hole, which cannot be achieved by the laser beam machining process. For observing the process of machining, an optical beam system consists of lens and prism is also incorporated. In EBM process, the beam controlled by very accurately and focused on the width as a small 0.002 mm, and which the electrons formed in the electron beam EBM process impingement on the workpiece surface and rise its temperature value of 5000 degrees centigrade. Due to this, the material melts and vaporized at the machining area. So the heat affected zone is very less in EBM process because of the machining area is very narrow. And nowadays, recent development in EBM process, it is possible to machine outside the vacuum chamber. Because of in this arrangement, the necessary vacuum chamber is maintained with an electron gun proper removing of gases as soon as they enter. So the EBM process full vacuum system is more costly, but it has the advantage that no contaminating gases are present during the chamber, and the electron gun can be located at considerable distance from the workpiece. So the minimum gap between the workpiece and machining zone. So electron beam have many advantage. Very hard heat resistance material, can be machined and welded easily. No physical metallurgical damage result in the workpiece because of very rare region. Close dimensional tolerance can be achieved because of no tool wear, and in electron beam welding, no contamination and close control of penetration is possible. It is the big advantage for the EBM process. In this process, we can create a minimum diameter of holes about 0.002 mm diameter can be easily drilled. So this process is very useful for very small diameter of holes. Disadvantage of electron beam machining: the equipment cost is very high and required of a skilled operator. Power consumption is very high, and it is not suitable for sinking deep holes if the sides must be parallel. In other words, it is not possible to have perfectly cylindrical deep hole by these methods. Unless special care are taken required, for the bottom of a through holes would become a cone shaped. So we provide a backing materials on the exit side of the workpiece. It is more suitable for machining operation where less material is to be removed. The material removal rate is of the order of fraction of milligrams. And last disadvantage of EBM process: the electron beam operation can be carried out in a vacuum. So the electron beam machining process is required a vacuum chamber. Application in industrial and power generation field. It is very useful for the watch industry because of in watch we use of very small components and holes about 0.5 mm diameter is very hard material, can be easily drilled, suitable for welding of small pieces, highly reactive and refractive metals, and it is very useful for fine gases orifice in space nuclear reactors and turbine blades and for the supersonic aero engines. And it is also used for wire drying dies. Flow orifice could be produced by this process. Fine copper wires can be welded to in transistors. So EBM process is very useful for industrial and power generation field as well as nuclear and turbine sector. Last is the difference between EBM and LBM process. In EBM process, a high intensity of beam focused electron and used to supply heat for material removal. But in laser beam machining process, a high intensity of beam of laser is used to supply heat for metal removal. And EBM process is carried out in a vacuum chamber to avoid collision of electron with air molecules. And here LBM process does not require vacuum chamber. It can carried out in open atmosphere and sometimes in the presence of shielding gases. EBM process is suitable to small component as the work is required, keep within the vacuum chamber. And here in LBM process, workpiece size does not cause any restriction as LBM can be carried out in open environment. EBM is applicable at conductive materials only, but LBM independent electrically conductive of materials of workpiece. Optical properties of workpiece surface does not influence EBM process capabilities, but LBM process capabilities relies on optical properties of workpiece surface. X-rays generated during EBM process, but in laser beam machining process no X-ray generated in this process. EBM process is time consuming, mainly due to creating a low pressure vacuum chamber, because of in electron beam machining we need of a vacuum chamber, but in laser beam machining its time is sufficient, no limitation of time, that is the fast process in comparison to electron beam machining process. So here we complete the electron beam machining process. Thank you class.